Dear students, welcome to this tutorial. Today we are going to read about exponential equation. And my dear students, this is the first class we are reading exponential equation. So you are students of class 9. This is very new topic for you. So I must define exponential equation, and you know very well we have already completed one topic, that is laws of indices, and I hope you know about all laws of indices, because this topic is a little related to laws of indices. So here also somewhere we use the concept of laws of indices. You know very well, very important rules. In multiplication we have the powers, in division we subtract the powers, zero index we write the value 1, while using power of index powers are multiplied. You know about how to use law of negative index as well. You know how to use root law of index as well. So this topic is a little similar to laws of indices. So my dear students, don't forget the laws of indices and how to use them. But what's exponential equation? Here is one of equation. About equation you know very well. You have already read how to solve linear equation. In class 8 you read how to solve simultaneous equation by graphical method as well. So I am not going to define equation, but I must define exponential equation. Let us consider 3 to the power x equals to 9. Let us say 27. Here 3 is the base, x represents power or index. Here 27 base, 27 has the power 1. Here this one equation, because here we have the symbol of equality. So such equation where variable appears as exponent, the equation in which variable appears as exponent, that type of equation we say exponential equation. So in general we can do say the equation written in the form of a to the power x equals to b is called exponential equation, where a and b are two constants, x is variable. So the equation where variable appears as power or exponent, that type of equation we say exponential equation. So you can give some more examples. 2 to the power x equals to 8. Here x represents power, x is exponent, and this x is variable which has appeared in exponent, or x is power here. So this is also one example of exponential equation. So in general we can say the equation written in the form a to the power x equals to b is exponential equation, but you should know a and b are two constants, x is a variable. So my dear friends, this is totally new topic for you. So I must tell you the concept of solving exponential equation. Here I have one mathematical sentence: x to the power a equals to x to the power b. X represents base, a represents power. X represents base, b represents power. Here you can, if you do study this, then x is the base, x is the base. The bases are equal. X base, x base, the bases are equal. A is the power over here, b is also power. That means if we do have this type of relation in mathematics, x to the power a is equals to x to the power b. That is, if the bases are same, here the bases are same. That means if the bases are same, the powers are equal. This is the first concept we do use while solving exponential equation. I repeat, x to the power a equals to x to the power b. See, both bases are same, and if the bases are same, the powers are always equal. As the bases are same, powers are equal. So now we have y to the power a equals to y to the power 3. Here also we have y base, y also we have y base. The bases are same. If the bases are same, the powers are equal. That means we can say the relation between a and 3 is a is equals to 3. That means if the bases are same, the powers are always equal. This is the first concept we do use while solving exponential equation. And the next one. But next concept we have x to the power a. You know very well x is the base over here. A represents exponent or power. Y is the base. A represents power. And you know very well here the powers are equal. And if the powers are equal, you can use the concept the bases are also equal. If the powers are equal, the bases are equal. But the main thing while solving exponential equation, we use the first concept the most. Don't forget, my dear students, if the bases are same, powers are always equal. If the bases are same, powers are equal. I said this is the first concept we do use in most of the problems in the topic exponential equation. But sometimes we use this type of concept also. This is just opposite. If the bases are same, powers are equal. If the powers are equal, the bases are also same. So while solving exponential equation, we use these two concepts the most. But sometimes, you know, in lower classes you might have read squaring on both sides, one concept in mathematics, cubing on both sides. That is sometimes we use that concept also. But if we do say both sides can be raised by equal power. So if we say squaring on both sides can be done, cubing on both sides can be done. Both sides we can raise by the power 4 also. If we have x is equals to y, then x square equals to y square also can be written. This rule you read already. We say squaring on both sides. If we have x is equals to y, x is also equals to y cube. We say cubing on both sides. If we have x equals to y, then x to the power 4 is also equals to y to the power 4. It means both sides can be raised by equal power. So don't forget this concept also. But the main two, if the bases are same, the powers are equal. If the powers are equal, the bases are same. If the bases are same, powers are equal. If the powers are equal, the bases are also same. This concept we use. So let us solve very simple problem. Here I have one problem A, one number solution. We have 3 to the power x is equals to 9. Then one thing while solving the problems from this topic, my dear students, in most of the problems we solve by making equal bases. Because we know if the bases are same, powers are always equal. Then one variable 3 to the power x equals to 3 to the power 5. If we have this, check, 3 is the base here, 3 is the base right side. It is the bases are same. Then what is the relation between x and 5? They are equal. X is the power over here and 5 is the power right side. These two are also equal using this concept. It means if the bases are same, the powers are always equal. So let us use this concept. Okay, we have the first problem. The question comes by saying solve, because the question of equation comes by saying solve. Solve the equation means we should get the value of variable given in the equation. So here let us say 3 to the power x equals 3. So right side we have 9. What is the base over here on the left side? 3. What is the base on the right side? 9. Are the bases same? No. If the bases are not same, we can't use this concept directly. So main thing we should make same bases. So right side we have base 3. Let us try to make, left side we have base 3. Let us try to make right side also the base equal to 3. So let us change 9 and the base something power of 3. That is, let us make both bases equal to 3. Left side we have 3 to the power x equals to right side we have 9. And 9 you know very well, 9 is 3 square is equals to 9. So 3 square can be written. But my students, you can ask why we are writing 3 square right side in the place of 9. If we write 3 square, then only the bases will be same. To make same bases, we are writing 3 square in the place of 9, my dear students. So 3 to the power same copy, 9 is 3 square. If you have 27 sometimes, by the time we have 3 cube to make equal bases. So after this use the concept we have already talked about the main concept. If the bases are same, the powers are equal. Means here we have already made the bases same. But if 3 same base, we have the power on the left side, yes. Power on the right side we have 2. We know very well if the bases are same, the powers are always equal. You can consider 3 cancelling mine and x is equals to 2. So x power on the left side, x is equals to 2. But if the bases are same, the powers are equal. Therefore, x is equals to 2. This is the value of x. So just make equal bases on the both sides, then is the main concept. Then one more, we have the question number 2. Its solution is starts. We have the I1 so 2 to the power x equals to 16. Okay, on the left side we have base 2. On the right side we have base 16. Are the bases same? No. Can we use the first concept? No. Because the bases are different. So let us make the both bases equal to same. But it's 2 to the power x, copy it same. Right side we have 16. So let us make the base given on the right side also equal to 2. 2 make equal bases. And do find prime factors of 16. You know very well 16 is 2 to the power 4. 2 adds 16, 2 4 is 8 and 2 to the 4. But the 16 is equals to 2 times 2 times 2 times 2, that is 2 to the power 4. So 2 to the power 4 can be written. Then only the bases are same now. But my answer, you can ask why we are not writing here 4 square. Because 16 is also equals to 4 square. But if you add 4 square over here, the base will be 4 and let's say we have the base 2. The bases will not be same. So we write 2 to the power 4 to make equal bases. Now base symbol 2 are same. I mean the bases are same now. The bases are same. Where x is equals to power on the right side 4. The bases are same. You can use 2 to cancel in mind. X is equals to 4. So if the bases are same, the powers are equal. Therefore, x is equals to 4. This is the answer. So I solved one type problem. Let us solve the next type. Okay, 3 number this type you can do solve by yourself. Only you have to know how to make equal bases. Then after making equal bases, you can use the concept if the bases are same, the powers are equal. Let us talk the next. If we have question number 4, we have solution 27 to the power x is equal to 3 to the power x plus 4. Well, now check. On the right side we have the base 3. On the left side we have the base 27. Are the bases same? No. Can we use the main concept? No. Because the bases are different. So what is the idea? We must make both bases same. So let us make the first base. I mean on the left also let us make the base equal to 3. Here is 27. Do you find the prime factors of 27? 3. 9 is 27. 3 is 9. But then 27 is equals to 3 cube. So let us write in the place of 27, let us write 3 cube. 3 cube. We have whole power x, do copy it, same. Then I have 3 to the power x plus 4. Well, after this, then here, I have already told you, you should know about using the concept of laws of indices. So 3 to the power, here, let us use power of index. The powers are multiplied 3 times x. 3x equals to 3 to the power x plus 4. Then after this you can do solve easily because the bases became same now. 3 same base. Then what is our idea? If the bases are same, the powers are always equal. Then what is the power over here? 3x is equals to what is the power on the right side? X plus 4. But if the bases are same, the powers are equal. Then after this, we must solve to get the value of variable. Let us solve 3x, take it on the left side, minus x is equals to 4. After this, these two can be simplified. 2x is equals to 4. After this, x is equals to 4 upon 2. 2 2s are 4. x equals to 2. Therefore, x value is equals to 2. Answer. So anyhow, make the same basis. Then after, use the concept as the bases are same, equaling the powers. We can do say if the bases are same, the powers are equal. So the next one, you can use the same concept. So let us start the next one more. Okay, if you do the question on our next and similar to this, 2 to the power 3x minus 5 equals to 2 to the power minus 5. Now this is more easier than the problems which we have already taught, because check the base 2, check the base on the right side 2. Are the base same? Yes. Can we use the main term directly? Yes. So 2 to the base are same. Then directly this concept can be used. What is the power over here? 3x minus 5. Because right side we have minus 5. So this can be used directly because the bases are same. And then after this do solve. 3x is equals to this minus 5 same. This same copy, the minus 5 goes back plus 5. Then after this 3x is equals to minus 5 plus 5 gives 0. Well, x is equals to 0 by 3. Well, x is equals to 0. Therefore, x equals 0 is the answer. You know very well, my dear students, 0 divided by anything, the quotient is always 0. So, if the bases are same, directly use the concept. So, I want to solve one more. Okay, let's solve the last one, 10 number. Okay, solution. We have the problem 5 to the power x minus 3 equals to 1. Okay, just check the bases first. What is the base on the left side? 5. Right side 1. Are the bases same? No. So here this very simple problem, my dear students, but you should know how to make equal bases. Here is the base 5. Right side we have the base 1. So let us make equal bases. Here is 1. So use one concept. You know very well 5 to the power 0 gives 1. 2 to the power 0 also gives 1. 7 to the power 0 also gives 1. So 5 to the power x minus 3. Do copy it same. Right side we have 1. So in the place of 1 we can do that 5 to the power 0. But my dear students, why we are not writing 2 to the power 0? Because 2 to the power 0 also gives 1. But if you do not 2 to the power 0 over here, then here will be the base 2 and here base 5. The bases will not be same. So if you have 2 base, by the time in the place of 1 we will have 2 to the power 0. So here the base is 5, so right side also in the place of 1 we will write 5 to the power 0. After this, check the bases. 5 and 5. The bases are same. And what is the power over here? X minus 3. Right side we have 0. Then what concept did we use? We have used the same concept. If the bases are same, the powers are equal. Then after this x is equal to take 3 backside, and 0 plus 3. You can do that directly, plus 3 also. Where x is equals to 3. You know very well when minus 3 goes back plus 3. Therefore x is equals to 3. This is the answer. So I solved some problems for you from this topic. But my dear students, one very important thing, if we have 2 to the power x equals to 4, here x represents power or index. While solving this, do always make both bases same. 2 to the power x equals to 2, 4 means 2 square. Then after this, if the bases are same, powers are equal, that means x is equals to 2. But we may have 2x is equals to 4. Here x does not represent power. These two are different. Here x represents power, here x does not represent power. If x represents power, we always solve by this way. But if x does not represent power, you know very well, here you can use the concept of solving linear equation 4 by 2. then 2 2s are 4. 1 another x equals to 2. So don't worry my dear students, these two are different. So if you have to represent power by the time, use this type of concept, make same basis and use the concept. If the bases are same, the powers are always equal. So today we read about the exponential equation, we read about the concept of solving problems by using the concept of exponential equation. So in our next class we shall solve some types of problems by using the concept of solving exponential equation. So my dear students, I have copied some questions for you on the board. To solve these questions written by me on board is our duty. I hope you will try to solve, to practice a lot, and don't forget to like and subscribe Great TV. Thank you.